think so,
We
yeah.
have to go downstairs. We've got a backup venue. One floor down on the ground floor. They buy nothing outside.
Yes, yes. I was going to stream down.
Yes. So once we full here, I'm going to send them out downstairs. opened up the venue on the ground floor as well, and we'll live stream down. So if you want to be comfortable for the morning, I recommend doing that. There's open seats, squeeze in, make a body. The spots over there, spots over here. Right, settle, get yourself comfy. It's going to be a long morning, so get yourself comfortable. If you've got a friend who's still coming, send them to the ground floor then. Right. Make yourself comfy. Okay, that's a smart move. Alright, we'll just keep a couple more minutes thinking in. But more importantly, welcome to BIM Community Africa. And we're inviting you to be part of this community, and we're going to explain to you why it's so important. And we're very grateful that you're here, because it's really important for us to work together in the built environment. And we're doing this so that we can do that. So I'm going to just start for the day. My name is Kalei Davey. I'm in the Department of Architecture. I'm also in the BIM community, which a lot of my friends are in the professional world, and we're inviting you to join us there. And today we're going to talk about the future of work, and we're using building information modeling as our vehicle to get there. Before we start, let me just check that we've done some housekeeping. We want to say very much thank you to our frontline sponsors, Baker, Baines and Modena. You'll see their stands all over the building. They are incredibly generous sponsors, and without them, we wouldn't be here together today, and without them, the community wouldn't exist. So we're very, very grateful for them. Please check out their please check out their exhibitions, ask them questions. They're here for you. They want to know how they can serve you, and please engage with them. They're not the only sponsors. We are a community of people from industry and technology, from construction to engineering to architecture to planning, from geography. We're all working together on this issue called the digital built environment. So thank you very much to Agile Business Technologies, to Dell, to Tarsus, to Esri South Africa, Hilti South Africa, HPA Architects, TotalCAD Architecture and Engineering, SOM Surveying, the Department of Architecture, BIM Community, York Brothers Construction, and obviously Zutari, who's going to take a big lead in today's events. So thank you to our sponsors. My clicker. In general, I just want to organize you, because who's from Bokende? Hands up. Great. You're the hosts, so be nice, ne? Who's not from Bokende? Who's from construction? Hands up. Real estate? Okay. QS? Who's a QS? Yes. Finally. Who's a builder? Who builds stuff? Builders, contractors? Yes. Planners? Any planners in the room? Project managers? We'll get you next time. All right, so architecture students, be generous hosts, help people around, let them find things, and help the guests as well. But in general, artisan coffee is outside. You probably saw it. Take a grab of a coffee there. Vida E-Cafe is in the basement, in the courtyard. Please go and visit it if you're hungry. If you want more things, go to the campus restaurants. They're not very far away. 2-minute, 3-minute walk, and you'll be there. Clear as mud. There are restrooms on every floor. They have a sign. They are unisex restrooms, so please just be mindful of that, and they're on that side of the building on every floor. And emergency exits are pretty obvious. Where you came in is where you go out. So down the corridor and exit to the front doors or the sides of the buildings, as well as the back of the hall. Yeah, and if you really have trouble, ask Vita. She knows how to do it. Use your words. Okay, great. So clear as mud. Let's move on. We are live streaming this event. So if you'd like to send it out to a friend, a family member, or a colleague, or a boss, or an employer, or whatever you're doing, please do so. We'll make it available after the event as recording so you can refer back. Okay, I'll give you a minute to snap this one. I hope it works. If it doesn't, we'll put a link on the website as well. If there's any problems, we'll fix it later and we'll send out new links. Yeah. Happy? Cool. All right, so BIMHarambee is a 2-day event. Today is day 1, tomorrow is day 2. It's basically broken up into mornings and afternoon sessions. Today, we're doing what is BIM, because a lot of us have very many different ideas about this world, and we need to figure out how we're going to come together, and we'll be demonstrating that through live BIM workflows as a team, and you'll enjoy that. And as soon as we're done with that, you have the whole afternoon to go and play with the toys, ask your industry questions, and engage with the built environment professionals. So please do so. I've got exhibitions from the ground floor all the way to the top of the building, and we'll go into detail a little bit later. All right. Tomorrow we have 2 sessions. In the morning, it's focused on students and young professionals. And we're going to be speaking directly to you about how to start a BIM journey, what you can do with your career. We have really wonderful speakers. I'll go into that in a minute. And for the educators, in the afternoon, we have an education focus. But we'll also be showing a case study that we're working on right now in the built environment. You're welcome to attend as you want to. It's just there's going to be a slight shift in the focus. All right, so students are welcome to come to the case study if they're interested. The case study will also be explained in the foyer. I'll show you in a minute. All right. So today, if you're here, in the morning we're going to do the real live BIM, and we're also going to do live scan to BIM demonstrations. And we also have scavenger hunts using the technologies. So please go find out which vendor has a scavenger hunt and go scavenge. And you might win a couple of prizes by playing with the toys. So we really encourage you to do that. And please ask questions. There's no dumb question. Everyone's a beginner. Please engage and make friends. Tomorrow, this is your lineup. Everything is in your BIM book as well. So if you get lost, use your bookie. But just to give you an overview, in the morning we have the South African Property Association coming to speak to you about PropTech and what's going on in that space at the national level. We're going to talk about the details of BIM, the workflows, what's important, and so on. Then we're going to explain the outcomes of our live scan to BIM process, which is happening today, and as Richard will take the lead on that. In the afternoon, we'll talk about the national level digital built environment in South Africa, what's going on. And most important, I think, for you as young professionals is what do I do with my career in BIM? And we've got a beautiful speaker from ACOM, who's the digital lead Europe, who's going to be speaking to you about careers in BIM. This is discipline agnostic. We don't care if you're an architect, engineer, a planner, a QS, it doesn't matter. BIM is agnostic to that. In the afternoon, for the educators, we're following a similar approach, but an education focus. And we will be talking about 2 o'clock for the case study of BIM and circularity. We'd really like you to come see that, because that's how we are practicing the teaching of it. And we'll also be talking about what skills would graduates need to do this work in the built environment. So please join us. All of our events will finish about 3 or 4 o'clock every day, and then you're free to go home and avoid traffic. All right. So before we start, we just thought it was important to set the scene a bit, because we have a legacy in building that we need to think about, and we tend to think of it not as a unit. We think of it in our discipline, we think of it in our project space. But I would like to ask you a very big question, which is, how many buildings do you think there are in the world? Take a guess. I need a number. Give me a guess. Okay, Willem, that's a bit much, but good guess. There's 100 billion buildings in the world. Everything from huts to skyscrapers. How many people are there in the world? So if you think about the numbers of buildings, not rooms, not apartments, not homes, not units of living, to the numbers of people, what's that ratio? How many cars are there in the world? Vehicles, all vehicles. There's 1.5 billion cars in the world. How many buildings versus cars versus people? The majority of these buildings are in Africa and will be in Africa in your lifetime. By 2026, in 18 months, we'll be at this number of square meters of buildings. Not roads, not bridges, nothing else but buildings. 1 to 10 per person. So by 2050, the majority of the world will live in urban environments. Doesn't matter the density, doesn't matter the scale, doesn't matter the location, doesn't matter the quality. The world will be urban, guaranteed. There's no other way. But the thing is, cities only occupy 3% of the surface of the earth. Cities are responsible for 80% of energy consumption and 75% of carbon. If you go to the doctor with this sickness, what would he tell you? All right. So obviously we say as a community, we must prioritize the upgrading of buildings that we already have so we can avoid the crisis that we're causing. We are way worse than cars, we're way worse than anything else by a factor of 10, minimum. But the problem is, the new buildings might be more energy efficient, but 80% of the world is already constructed. So with these things in mind, the built environment has a huge role to play in the future. The immediate future, tomorrow, as in Tuesday, not in 10 years. In Africa, it's a bit different. In Africa, 70% of the African stock needs still to be constructed. Africa is a little different. Our context is different, but it's the same trajectory, right? And every 20 years, every city doubles in Africa, in size, scale, complexity, magnitude, everything. There's a lot of work to be done on this continent for the built environment. But if all the buildings are already built, and they will be built very soon, in your own career, your 5-10 years that's coming, how long do we have to take care of these buildings after they are built? Right? It's not just build the building, we already have the building. What about the life of the building? On average, a building wherever you go, is 70 years old, including the one you're sitting in. It's a human lifetime. That's how old buildings are. They live longer than us, much longer than anything else we're busy with. There are buildings older than the industry of motor cars and vehicles. Buildings have lived beyond that. Buildings have lived through industrial revolutions. They're still here. So the average building is 70 years old. You can see that in Tux. The University of Pretoria is the second largest asset owner in the city next to the city. We have 1,000 buildings, literally. Right now, 400 of them are already heritage buildings, and that number will go up. So if we talk about the life of the built environment and your job in it and the real big picture in your own lifetime, never mind beyond your lifetime, let's do some napkin math. I love napkin math. Let's pretend the average building design and development phase, average, maximums, is 3 years, right? Yes, there's exceptions now and then, and so it goes. But the average building takes 3 years to develop and design, right? And let's say it's 3 years to construct, okay? And if you work in a high-performing environment, like Europe, America, Ireland, whatever, those high-performing regions, that time frame is shorter. It's almost 12 to 18 months to build and construct and be done with it. But that means 6% of our effort of a building's life is in design and construction, but 94% is in the life of the building. Operations, maintenance, use, energy, etc. If you go to the doctor with this problem, what would he tell you? We need to think differently about the built environment. We can't do it alone. How are we going to create a human habitat that thrives? How are we going to do it in Africa? How are you going to do it in your own lifetime? What is your legacy going to be when you leave this building? This is why BIMHarambee. And Maloka reminded me why we use this word. What does Harambee mean? I heard it. Someone had a yeah, what does it mean? To pull together. To swim together, to be together, to do work together. That's what Harambee means. It's Swahili and it's Pedi for that word, right? We can't build these cities of Africa if we don't do it together. It's impossible. So we are here as a community, and we're inviting you into this community to say, how are we going to build the digital world to help us service the physical world, building cities, communities, and environments? How are we going to do that? But before we get together and do technical things, we need to change our culture. Our culture for building isn't working for us. And it's not my job today to go into the details. You'll find it out very soon. If we don't change that culture, it will not change. So before we do tech, we must do culture. And we're here at Harambee to talk and show that culture to you. If we can't build these future worlds if we don't do it together, I mean, it starts with human behavior. We can do amazing things with technology. Go and have fun this afternoon, go play with the toys. We can all do these things, but if we don't do it together, it doesn't matter. Doesn't matter at all. We can do incredible things, but if we don't do it together, there's no point. And together means everybody must share a reality. And the digital world helps us with sharing that reality. It's very powerful in that way. The digital world helps us to come to consensus, to agree, to negotiate from the same page, to see the same world. The digital world doesn't mean it's not part of the physical world. It's interlinked. It's the same thing. We're living in a social, digital, physical, interconnected 21st century. Doesn't matter your discipline, your story, your background, your personality, that's the truth. And the built environment must work together like that if we want to see thriving cities in Africa. End of story. So with that, our goal today is not to show you perfect projects. That's not the point. The BIM Community Africa is here to show you how to behave through BIM to create projects. BIM behavior is the way we want us to shift culture, and we'll show that to you today. with our team. Click. And I want you to start recognizing that it's a collective activity. There's no single person here in the BIM community or the value chain that has a hierarchy above someone else. It's a stupid idea. We're working horizontally, we're working together, and that's the culture we need to shift. So with that, this is the community's ethos. I'd like you to think about it when you go into work. Leave your badge at the door. I don't care where you're from, I don't care what you know. If you're not working together, you're not working. Do something good for somebody else first. We'll talk a lot about that today. And take care of the future while you do it. If you don't do any of this, don't bother working. So to do this, we're going to explain to you how to BIM. And that's what this morning is going to be about. We're going to demonstrate that as a team. And then tomorrow we'll go into the nitty-gritty. So before we BIM, before we lift a pen to paper, before we even say what is project, we say why is project. Why are we here together doing anything at all? All right? So in BIM, we think of the whole life cycle of the project, not just my job. And the why is, how does this project, which is going to outlive me, outlive all of us, how's it going to matter in the future? And to do that, we work in work stages. So most of us are used to the work stages of professional worlds, right? 1 to 6, architects, QAs, whatever your story is. Well, everybody works in a train, right? But in BIM, we have extra stages. We have stage 0, which is mega, 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 mega important. And we have stage 8 and 9, which is becoming very important. But it's helpful to think of this, that in BIM we serve forward. We don't finish our task, we hand over to the future. So it's more helpful to think of it as the first stages of BIM is ready for development to take place. And once we hand over to the next team member, they prepare the project, whether it's a building, a bridge, or whatever you're doing, to be ready for design. And they hand over to be ready for construction, and they hand over to be ready for operations, the biggest job. And they hand over for decommissioning and recycling and circularity at the end. And this is a full circle that we think about. But to do that, we need to set the culture before we do the tech. So I'm going to start, and I'm going to role play the owner of the project. I'm the owner, I'm the project owner, I'm the client, insert synonym X. That will be my job. And I'm going to hand over to my team members as we simulate the BIM process. So my first job as an owner is to understand with my team, why are we doing this at all? And when we as BIM community thought about BIMHarambee this year, we said, how are we going to think about BIMing for you? How do we serve you? And we got together and we started saying, okay, we need to talk about stuff. We need to talk about BIM in Africa. That's what we need to do. We have to talk about the tech. We need to talk about the how. We need to talk about all of these things, right? We have to demonstrate things. We spent a lot of time talking about that, and still we started listening to each other and hearing that maybe there's something more valuable to do than just show you BIM. Maybe we should talk about, where is my clicker? That BIM is bigger than us. It's an excuse to work together. Maybe BIM and making building information management and modeling works is about creating intelligent processes, not smart buttons and products. It's a way to work together better, right? Maybe BIM, as a catchword, is about better information management for someone else, as opposed to just for you. You don't matter in the team, it's us. Maybe BIM is about leading and serving others to help them come along on that journey. Maybe that's what BIM is about. Maybe we need to do that by changing our behavior. Maybe we need to show that to you, right? So maybe BIMHarambee should be about making a new generation of African built environment experts and specialists who know how to do process-driven work, and who know how to collaborate together. Maybe that's what BIMHarambee is about, not the textbook. And with that why, our strategic definition of why we BIM, we planned BIMHarambee together to create the most value for someone else and to serve someone else. Do you see how different that is to traditional construction and design? Do you see how much better that can be if you work together from the start? We have not designed the project, we have not lifted a pen to paper. It's not about that at all. It didn't cost us a cent to build consensus. So we planned BIMHarambee around those two questions as our strategic definition. So now I'm going to hand over, just so we have a bit more context, to Richard Matchett, who's going to talk about the what and how of BIM, and then we're going to launch our simulation for you. All right.
Morning, everyone. I'm a civil engineer, and I didn't really know much about BIM until probably about 7 years ago, when I started hearing about this acronym BIM. And since then, I've learned a lot of different things about technology and processes, but I've had to explain my job to my parents, and that's helped me break it down to manageable ideas. And when I explain it to my mom, I say, Mom, it's a process where we create information and we share that information in teams, and we use it basically to build stuff and to create value on stuff. Now, she understands that because my dad's an engineer. She's married to a family of people that are involved in construction. And it's been great to tell her that, Mom, we don't draw stuff anymore. We model stuff. And she's, what do you mean? Why? Well, Mom, because then we're able to share the information with teams and we get over all those bottlenecks that Dad always complained about. And that's been a really great way to think about it in my own career, is as professionals and as you guys move into the workspace, that's the ethos that we're embracing more and more in the professions, is sharing information so that we can achieve really good purposes. Now, the way that this works practically is any project that you're going to be involved in is going to go through multiple stages. And so if you break it down between these different stages, there's a lot of work that goes into each stage. And ultimately going from design through construction into having an operating facility, whether that's a building or an airport or a pipeline or a dam. And that value is then created for the world that we live in, for the generations that are to come and for us to enjoy. But as this gets created, you have this incredible shift from us that are involved in projects, we create things, to other people who are involved with actually using those things. Historically, that's been a great challenge. Historically, the transition from the building stage to the using stage has been the challenge. One of the big challenges is when you finish a project, there's a truckload of paper that needs to be given to the owners or the operators, and it's very impractical. Whereas with digital or electronic information, it opens the doors to be able to search and find for information and make better use of it. And as all of you know, we're in the smartphone generation at the moment. Information drives decisions. Information helps you to understand what's going on. And so the process of BIM is partly creating, partly sharing, and partly empowering the entire life cycle of assets that we're involved in. Now, those truckloads of information, it's still truckloads of information, but now it's digital. So anyone who's got a Dropbox account knows that your information gets messy very quickly. So it's very important to manage information, right? Otherwise it becomes a hassle rather than a help. So you need a few things. Number one, we need a standard, because all of us, wherever we're going to end up working, we need to work in a consistent manner. Otherwise it's very hard to align and to get things done. So South Africa, and most of the world, is busy adopting this ISO standard, which defines how to create the information collaboratively, how to share, how to pay it forward, how to consider each other in the design and construction and management process, and how to make sure that that information is of a high enough quality that it is useful. You need a team. We spoke a lot about teams, and one of the basic fundamentals around working together is The better you share, the better you work, quite simply. And the more you share, the more information drives understanding and common knowledge, the less mess-ups you get. And that's a fundamental principle in any projects. You need a plan. You need to know who needs to do what, when, how, why, and that needs to be spelled out. And we'll talk a little bit about that this morning. Very important, you need a workflow, because you start somewhere and you end somewhere. And the steps in between can be very complicated. And so more and more it's important for us to map out those steps in detail one by one, so that each person in the value chain knows what do they need to do, how do they need to do it. And then you need some tech, you need tools, from computing power to measuring instruments, from things to understand what is, to other things to understand what will be, and to communicate that with all the stakeholders. This is a bit slow, isn't it? So how does all of that relate to our work? So I'm going to come back to these stages and say that this stage definition that Khaled introduced just now is incredibly useful to plan the workflow throughout any project, from the beginning to the end. And so for the rest of this morning's session, and then we're going to go and have a look at the exhibits and demonstrations, we're going to spend time looking at what happens in each stage. And then when you go out of this room, you will see what we've talked about briefly now. You'll see this in practice, and you'll be able to talk to companies that are using technologies or workflows exactly what we're explaining now. You'll be able to go and ask them specific directed questions. And I encourage you to think about how is your area of study, where are you going to end up working, what type of work are you going to do, and how does what you see today spark an interest of how you think you're going to be doing things. I also encourage you to take what you see today and blend it with what you're learning, the textbook knowledge that you guys are gathering at the moment, and start seeing today's information as a method of how you're going to implement the theory that you're learning and turn that into practice in the world that you're moving into. So, let's have a quick look over here. Strategic definition. We've got to find out what we're going to do. Khaled's going to talk to that a bit. Then, as we get going on a project, before we actually start doing the math, drawing the drawings, figuring out the quantities, we've actually got to get that plan down. And a project plan is project specific. No two projects are alike. And so at the beginning of a project, the whole team gets together, like the photos of us sitting together, and figures out how we're going to get this thing done. Then we collect reference information. So a lot of our buildings are already in existence, as we said. So a lot of our projects are going to be about modifying what's already there. The sad thing is, what's already there wasn't very well documented, or it was well documented and the documents are missing, or they're out of date. And so these days we use technology in the industry to go and measure up and then reverse engineer or reverse draw what is there, so that we've got a baseline to work from. And then from that baseline, we're able to then create our initial concepts, make sure that everything fits together, and then go into detailed design and planning, where all the different disciplines get together and make sure it still fits. Something that happens all the time is you get a great concept, you start designing it, and things just fall apart. A big part of what digital technologies and design enable us to do is to keep fitting the pieces together, so that we make sure that they keep fitting through the design and development phase. Then someone's going to tender for the work, start working on it, and then things get really exciting. The yellow machines arrive on site, you start digging holes, building walls, building things, and that's where, as a professional team, we need to make sure that we're able to see, is everything still on track? Are things happening the way we planned them to do? And then at the end of construction, is the end result properly recorded, so that we can hand that over into operations, go through into the operational phase, and then ultimately arrive at the end of life, preserve or change. And so that's what we're going to do now quickly for the next, I think, probably about an hour. And so what we'll do is I'm going to put this workflow on this screen. And then as we go through the storytelling, different people are going to come and tell you what's happening in each of these blocks. And so as we move through this, new speakers are going to come up. Keep track of where we are in the storyline. and keep track of where we are in the demonstration. So here's a quick hint. This building has been set up with the pink areas over there, collect reference information in the basement. And as you go through this timeline, we go up the floors. So depending on where you start and depending on how we leave this room afterwards, you'll then be able to see everything happening in sequence. So keep track of the presentations on this board, and then you'll be pre-educated when you arrive at the stands. Okay, so first up.
If you get lost, bookie.
Yes, if you get lost, bookie, and we'll remind you just now. All right, Caleb, you're up.
All right, are you ready? Okay, all right, so I'm going to role play owner. Well, I am the owner. We're the building owner. We are the Department of Architecture. This is our building. And as a BIM professional, as an owner of buildings, my first job is to say why build and what to build. We need to do strategic definition as a team and define the project. Before I even say, lift a pen to paper, what is the project? So we're going to talk about the project. We have a dream. It's called Architecture 5.0. And my job as an owner is to do certain things for the rest of the team so that they know how to work together and that we have consensus right from the start, not somewhere in the middle, oopsie, oopsie, oopsie. To do that, I need to pay attention to 4 important things. Really taking control of our project and making sure everyone is on the same page. That's my job. I must make sure that the information is helpful up and downstream, as well as when we hand over the project. I must make sure that we are contracting in a way that makes this happen and possible, and that we are aligning to standards, that we have good governance. And I must make sure that when we build, construct, hand over, maintain, that that culture is continued, even if I'm not in the room anymore. That's my job. So let's start at what we want. We want Architecture 5.0. That's our owner's project requirements. This is what we want. We want to upgrade the life cycle, extend the life of Bokende, and make it more useful for future generations. That's what we want. We want to create and practice together in this building in new kinds of ways so that we can create new kinds of professionals and practice as apprentices of the 21st century. That's what we want. To do so, yes, this clicker, I need a new one. We looked at our building and we said, what kind of a project do we want? Now, the interesting thing about this is the owner, I didn't come up with this idea, the team did, because we were talking about it together. I still am shocked by that. As an architect, I should have the big idea. But the team, because we're talking about that really early on, about purpose and culture, we said, sure, we must stay within our constraints. We have a limited budget. We have no money. That's a fact. So we can't go crazy on that, right? That's a constraint. Oops. But we also have principles. As a team, we have principles. Not just my principle as Mediclinic, Menlyn, building owner, beach house owner. What is our principles as a team? And our principles were, we will not mess up the world and we will not build another building. That's our principle. The other thing is, this building must be awesome. It must be awesomer than any other building. And it must be awesome for students and learning to take place. That's a principle. It must be way cooler than Engineering 4. Way cooler. And with these principles, the team said, well, shouldn't we build a kind of building that aligns to these things? And the most sensible thing to do is add 2 floors to the top. The building is strong enough, it's good enough. No, that's our plan. It aligns to all the principles, it fits into the constraints, it sets up our values together, it's possible for us to do it, etc. We've not lifted a pen to paper. So here we go. Bokende Architecture 5.0, that's the project for us. So we want put cool new labs and workshops on top. And we want a lot of creative environments to practice and make a mess in and so on. And it must show off all the topics we're interested in, and these topics will change. And these topics today include the York timber chair and timber construction. It includes living walls and green buildings. It is flexible facades, climate action, cities and futures, digital learning. This is the stuff we care about. We need to practice in that. We want those labs go do. So as a team, we're very clear on what the project is and what it isn't. We have not lifted a pen to paper. Okay. My job as the owner is to say, how do I take care of my team? What do they need from me to be successful? And what kind of information will the building owners of the future require? How do I act responsibly now? And in BIM, I need to take care of these 4 things. We call this the information needs, and there's other ways of describing it. Read your book. But for me, my job is to take care of the OIR, AIR, PIR, and EIR string of information. In other words, the organizational, asset, project, and employee or employer's information requirements. People who use the building forever. So I'm not going to go into detail, but the questions I ask myself as an owner is, for the OIR, what information do we need from this building and its design process to ensure that we make good decisions in the future and others can do their work? So in other words, I build a client to-do list for now and for later, right at the beginning, before we lift pen to paper. I also start asking questions with my team, and I find out from them, what essential information do you need to be able to do your job well? I don't prescribe it, we work together. I ask them, how can I serve you as the owner, as the client? We also ask, how are we going to manage our assets, from the brick to the computer to the human resource assets? And we say, at the end, we start with the end in mind. When the building is finished, doesn't matter what it looks like, doesn't matter how we get there, how we manage our assets. How are we going to govern this project? I ask, to make the project, it's a physical thing, what does the project require of me and my team? And the useful question there is, who of you need what, when, and in what way? How do you need information from us as a team? How are we going to work together? How are we going to hand this stuff over to each other? We've not drawn a drawing, not made a budget. It's not about that yet. And finally, I say, how will we make sure that we reliably do this? For now, during construction, and for the 94% of the life cycle of the building that's still coming. That's my job. That's my biggest job. And to hold that true through the project. So when we planned BIMHarambee, before we lifted a pen to paper, we also did this. We said, why are we harambeing for you? How are we serving you? How are we making value for you? And when we came up with this awesome project called Architecture 5, we planned the whole thing out without having a drawing or a budget or anything in front of us, and we did it in a day. Because we wanted to know, how are we serving everybody from zero to recycle and decommissioning? How does this work? How does the whole thing work together? Do we all know what we need to do? Do we have questions? How are we playing out this project without having a design in front of us? It doesn't matter. How are we going to work together? How do we make sure that every time we do something, when I do something for Michiel, for Verosha, for everybody downstream, that I produce value and I'm serving them, and that they receive in a way that they can serve someone else? Traditional design and construction never does this. Not once. Who's been in design and construction in the field? Who's had pain? Because we don't build consensus from the start. This costs us nothing to have a responsible conversation. Nothing. So now that we know how do we produce value and what we serve and what kind of building we have, now I can say, let's start. And this is how BIM kicks off. So I'm going to hand over to the next phase of the project. Modena, Sam, Hilti, Zitar, and Esri, we're going to talk about stage 1.
Right, so if the speakers want to come and join me over here, we're we're going to go through this quickly. So now that we've got the employer's brief, essentially, and all those different information requirements, well, the first thing that we needed to do as a project team is to put together an execution plan. And so the team at Modena then put their thinking caps on, took all those requirements, and then put them together into an execution plan that spells out exactly those questions. So who needs to produce what type of information, by when, give it to whom, in what format, and how are they going to use that? So a lot of you are working on team projects, right? And I think especially the architecture students, you guys have got late night deadlines, and the engineering students as well. I would recommend that you guys start putting together project execution plans right now. Because if you don't, you end up at that point where it's last minute and suddenly someone has a hissy fit, has a tantrum, and takes over, and tears are shed and sometimes blood. This is what helps the professional teams to avoid that tears and blood scenario. And every time these plans get put together properly, projects have a very, very strong likelihood of success. When they don't get put in place, the opposite often happens. So, once we have a project execution plan, then we need to move on into collecting information. So once again, this is an existing building, and so the team then needed to get all the necessary skills in place to measure up the building, figure out where it is, and that's what we're going to talk about next. Right, you're up. No, it's you guys. Wait. There you are. All right, I think you're going to press that one very close to the machine.
Okay. Stand in the block.
Stand in the block.
Stand in the block. Okay, hi guys, my name is BIMHarambee and I come from a company called Somsova Instruments, and today I'm going to speak a little bit more about the importance of accurate geospatial information. Alright, so great. So what is geospatial information and why is it important? So geospatial information is the concept of the whole Earth having coordinates. So you already make use of geospatial information on a daily basis, and I'm going to prove it to you. So let's say you want to go from point A to point B. Let's say from UP to a specific shop in Johannesburg. How would you get there? Waze. Maps. Am I right? Okay. So Waze and maps makes use of coordinates from point A to point B, and that's how you navigate. But that's just in a very inaccurate form. So what we want to speak about more today is how to take that information and make it a bit more accurate. Think about better accuracy. So
Point it at the computer.
yes, sir.
Yes!
Outside. Thank you, all right. Okay, so when we speak about accuracies, there's two main concepts that we can speak about: relative accuracy and absolute accuracy. So relative accuracy is typically when you have the most beautiful building in your head and you're designing it on your CAD software and you're super proud of this and you cannot wait to show your parents or family or even your boss at work, like, look at what I've produced. And you go to him and you say, look at this. And he says, okay, just export it into Google so that I can see where it plots. You export it and it plots in the middle of the ocean. That's relative accuracy. All right, it means that your scale is 100% correct and you do know the measurements of your building, but it's not plotting in the correct position or place. Sorry, I'm standing in front of you. So, and that takes me to my next point, which is then absolute accuracy. So how do we achieve absolute accuracy? Absolute accuracy is achieved when we make use of technology to determine precise points on the surface of the Earth. So it's taking your design and putting it, assigning coordinates to that design to enable you to know exactly where on the Earth's surface that design falls. And that is then absolute accuracy. Okay. So let's say you know where your site is now, but you've got this concept in your mind and you need to make sure that everybody that's going to visit your site is speaking the same language, and by saying that, I mean that everybody knows where a manual, if I say a manual is there on my design, everybody must be able to navigate to that exact millimeter accuracy of that manual position. Okay, and the only way we can achieve that is by establishing accurate site control. To establish accurate site control, we place benchmarks on a site with specific georeference coordinates that we can reference to later, whether you're an architect, a builder working in, I don't know, as a QS or whatever. If you want to check information, you all work from the same reference stations, and by doing that, we all end up knowing exactly where the corners of the buildings is, where's our stormwater line, and there's no mismatch, so we don't need to dig up what we have done or break down a building and rebuild the building on a new place because we didn't work from the same control system. All right. So, and to obviously establish accurate control, there's different types of technologies out there, such as GPSs, drones, laser scanners, and we'll speak to you guys when you come to our booth. We'll tell you all about the information and how to make your BIM projects as accurate as possible. Thank you.
I think it's just arrow keys.
Okay. Great stuff. How's it? Louis de Klerk. I'm from Zutari, and I'm our reality capture lead there. So yeah, we're talking about collecting and sharing information, and yeah, as an industry, we call this basically reality capture. It's a term that's been around for a few years now, but it is not that common yet. And to summarize that, basically, we digitize real-world assets by using technology and software. So it's not just about the tools and the tech. And then these reality twins become the geometric reference information for the rest of the process. Okay, so that's the first set. What is used in industry? We used to be there. You can still use that, but if you take something like Boken, it's going to keep you busy for a while. And we don't, yeah, when we get to accuracy, you're going to lose the plot there. So this is the range of tools that most of us use to capture information, and all of these have a very specific place together with all of the software to bring this picture together. So VM has already talked about survey control and how critical it is, but for the reality capture process, that's also the first thing that happens. So that doesn't only happen when we go to construction. Before we start collecting information, we make sure that we've got that critical base, that we know that what those fixed points are, and that we know everything is tied to those coordinates. Where's the rest, Richard? Something is... Keep going. Okay, I'll just skip over that one. Then drone photogrammetry. So there is no real such thing as a drone survey. A lot of people ask me for drone surveys. They don't really exist at this point. So we stick to drone photogrammetry. And that's basically the process of taking thousands of photos, sometimes hundreds of photos, of a specific structure, a specific site. And yeah, basically a drone being a flying camera, that's what we need. The tech side of it is, it can be anything that can capture that information. We can do it by plane or helicopter, but capturing those photos and then creating that reference, that reality twin of that site. And that's the outside skin. Next, we'll need obviously the inside. And that's where 3D scanning comes in. So using LiDAR scanners, you get them in handheld SLAM, simultaneous localization and mapping, for those of you that haven't heard that term, or the more common known scanners, which is stationary on a tripod. You move them through the building, all of them in various accuracies, but those capture the insides of a facility very, very, very accurately. So putting a high density scanner in a room like this will take 2.5 minutes to capture each and every piece of wood, speaker, light fitting, everything that's in this room, and you'll have it in 2.5 minutes. Obviously you need to do a lot of work downstream to create the actual model, but having that reference information, that's the step on the inside. We supplement that with 3D images, and Open Space is going to talk about that a bit more later, but having the visual component of that and bringing in condition of what is the condition of that element. And then what does all of this deliver? In the end, we want to talk about information. We need information. We don't just need pictures. The pictures are great, but we need the survey control, so we need those coordinates. The drone photogrammetry provides us with point clouds, 3D meshes, ortho photos, digital surface models, digital terrain models. So a lot of information that's used by various parties downstream to plan their work and to design their work. The 3D scanning provides us point clouds. It doesn't provide us a model. It provides us a point cloud. So again, the reference information to take us to the next step. And 3D meshes, and then obviously the 3D images. And then all of this have quite a bit of benefits. We've got rapid data acquisition. So you can capture a building like this with a scanner in a day easily. And you've got all of that measurement information while the drones are running on the outside. That information is geometrically accurate, like VM said as well. But talking about that relative and those absolute accuracies, that's where this technology comes in. Creating virtual site visits. We're talking, Glade mentioned carbon emissions and vehicles and all of these kind of things in the world. Bringing that site that's sitting in the middle of nowhere or sitting 500 kilometers from your office, bringing that back into your office where the rest of your project team, because you're not just one, can actually view that information. They can visit that site, they can understand it. There's a lot of projects where people have designed some of the biggest bridges in the world, and you're sitting with a lead designer and 10 underneath that person, and they've never been on the site where that thing is being constructed or designed for that matter, and they're designing it. How do they visualize it? How do they understand it? Bringing that site back into the office. We're documenting the as-built conditions. What is there? What do we want to work with? When we start working downstream, what did we change? We can use all of that information to create the detailed layout, the models, all of that, the fancy things that we're going to talk about later. It's the basis for our building information. It creates the location of things in space. And again, knowing where's the speakers, where's the light fittings, where's the aircon units, all of those kind of things. Remote analysis by experts. If you need something that needs to be checked by somebody else that's sitting 1,000 kilometers or in a different country, we're not constrained these days by being in the same office anymore. So again, making that information available to those people. And then the great thing, all of this integrates with all of the software we've got, with all of the other equipment, with all of the common exchange formats. So it's a thing where all of your information can talk to each other. And that's basically capturing the reality. So thanks. Thank you.
So one of the interesting things about buildings and measurements, like Louis just described and we're going through with the survey process, is you can measure what you can see, right? But what about the stuff you can't see? What about the inside of concrete columns? We're going to add 2 floors to the building. We need to be sure that the structure can actually take it. Well, then we need to analyze the columns. We need to know what the percentage of steel is. We need to understand the configuration of those columns so we can analyze if they can handle the additional load. So Hilti, one of their incredible technologies is the ability to scan the inside of concrete structures and then be able to visualize what those cages of reinforcement look like so that the engineers can then do analyses. They've also got applications that then help us to position the design elements inside a virtual space. So please go downstairs and have a look at what they're going to be demoing in the basement as well. So once we have all this information, it's a lot. And if I just go back to these, just the different formats, one of the things that teams often struggle with is, okay, but how do I use this stuff? You know, and these files are big. I mean, some of these files are 50 gigabytes. Yeah, right? It's like 5 Blu-ray, well, you don't use Blu-ray anymore. It's like 10 HD movies for one scan. You gather the information quickly. Louis, we took 2 hours to scan this building. 2 people took an hour and a half to scan the entire building, top to bottom, inside out. And the information was, how many gigs?
No, that's about 100 odd raw information.
100 gigs of data that we generated. You need a plan, right? And then once you've sorted out that information, it needs to go and live somewhere. So that's why we have applications like GIS and Esri, and we're also going to take us through some of that technology.
Yes, thank you very much, Richard.
Just use the arrows.
Yes, I will. Yeah. Thanks. Okay. Yeah, so I'm from Esri, South Africa, and I've got some colleagues here and some interns that we have in training as well. So thank you very much for this opportunity. So what is Esri all about? Esri is about the science of where. So where we want to find stuff, where we want to see things, and it's a geographic information system. So part of it, the science of where is location. I think we've got very good examples from previous presenters showing us the accuracy, how important is what location is, where things are. And we can go down from from continents down to cities, down to a speaker, as we mentioned, within buildings, within rooms. So where things are is very important. Then we also want to know what is around us. What is on this campus? Beyond the campus, what is in the city? Where do we get our water utilities, our electricity? If we want to extend the building or have other parts, like for instance, additional parking, where does those things come from? So we need to plan that. We need to know what is around this building that we are planning. And what are some trends? So do we see climate change? Do we see crime trends? Do we see other type of trends over time? How do we see the exchange? And we can also see some patterns emerging. So GIS is a very good platform that will help us to see these trends and these patterns. But I think what is great about GIS is the ability to model. So this is not a BIM model, this is modeling what-if scenarios. And we've seen it with some of the floods recently. So we could plan and understand where are those areas that are vulnerable to the floods or communities that are vulnerable. And we can model those and play different scenarios by using geographic information systems. So what we've done as an example, we've worked with the University of Stellenbosch, and we built a digital twin for the campus. So what you can see here is an example. I just want to see if my animation works. Yes. So we can look at the different facilities, the buildings, the sports facilities, and all the detail within. You can actually go and Google this and go to Stellenbosch website. You'll see exactly this view and this interactive application. The campus areas, the walkways, the facilities, the infrastructure. Because if you extend a building, you need to make sure that there's enough road infrastructure, utilities are talking to it, also the parking, the security, everything is related. So we need to look beyond the building and plan around it. So you can see some of the infrastructure, road, parkings, and so forth. Here we can see where other construction is taking place from a holistic planning of a campus. We want to know where and what stages of the different construction. We look at, for instance, parking planning. Interesting one here is also the trees. Where are the different trees? Where are the irrigation network, the water network? Everything around the signage, the security, and the different utilities. Here's an example of the Stellenbosch's fiber network and the IT network. Where do they have Wi-Fi areas? Where are the different networks? This is the same with utilities like water, electricity, stormwater on the roads, everything. So GIS brings all of this together and helps us to understand the environment. What we also want to show, and our standout down in the basement, we're going to show you a little scavenger hunt where you can go outside and collect some of these assets. So the idea is that you would use a mobile application, can be disconnected as well, so you don't have to worry about having data. So you can go out, it will navigate you to the location of that asset, you can verify the location, you can verify the condition, and this is where you also use devices that can be very accurate. But then you can go back to that meter or that transformer and actually get the condition assessment of that. So these are the type of examples of mobile applications. No programming required. You don't have to develop this. This is out-of-the-box tools that you configure, and you add your own type of questions and things in. So what are the main takeaways that I want to leave you with? So GIS is about where to build, about the site selection. It will help you to do the site survey with all these fantastic tools that are being showcased here today as well, but it will help you to find out where is the best location. We use it within the retail, we use it within banking, we use it in mining. So all these type of things are being used in even with agriculture. Site selection is quite an important part of GIS. Feasibility analysis, environmental impact assessments. There's for some of you need to develop a new building or anything. You have to provide an environmental impact assessment report. Department of Environmental Affairs has got a screening tool that you can do an initial assessment of if you're allowed to build a new filling station on the corner of so-and-so, and it'll tell you, yes, you're not allowed because there's some protected areas, there's a water stream close by, you can contaminate the water. So you can do that kind of thing. That's all GIS. Then accurate spatial data collection, we spoke about that, very accurate data. And then asset inventory management. So I just want to leave you with those kind of things. So please come down to our stand and we can demonstrate to you how these things work. Thank you.
All right. So, where are we on our map? We've finished our strategic definition, we've done our prep and briefing, and we've collected a lot of information. You haven't started the project yet, right? You haven't started designing. So this is the moment we've been waiting for. I'm going to ask Belinda to come up and take us through the first stage, which is that initial concept design, and making sure that we then are able to see what is this new building going to look like. So, welcome. I think just use the arrow keys.
Thanks, Richard. Morning, everybody. My name is Willem Viviers. I'm from Total CAD Solutions Center. We are the sole distributor of Graphisoft suite of products in South Africa as well as neighboring countries. So, I'd like to thank our client for appointing us on this very special project. And initially, or traditionally, as an architect, you would be involved in a couple of stages, possibly even further than stage 5. However, in this example, we're just going to be focusing on the conceptual, just quickly discuss a few things that we do in this phase. Right, so the architectural team collaboration, the internal collaboration of the architectural team, we use the Graphisoft BIM Cloud, which is basically allowing us to work remotely over the internet with no delay. And obviously, as you guys know, with pandemics and all of these things, it has become a necessity. So our team consists out of 3 members. Ronel, which is in KZN. We also have Gert, which is in Cape Town. And then myself, which is based inland. So the BIM authoring tool that we used here is ArchiCAD, which is supporting a open BIM workflow, which means that gives flexibility for all sorts of vendors to partake, which means it's a lot easier and flexible and open for more people to bid, and instead of having a closed ecosystem, and obviously there will be less possibilities of certain people being able to join project. Right, so starting off, before we could do anything specifically, we had to import the existing data. That could vary anything from a specific 3D format. In this case, as the BIM execution plan stated, we use IFC format. It's an open BIM format, industry foundation class, and obviously other information available. Not everything was in 3D, obviously, so DWGs and PDFs, whatever you might have, we had to bring those things in. And based on that, we then did a little bit of quality assurance, and I think it's important to do that to make sure that in the beginning of a project, going forward for all the other professionals in the next phases coming up, to make sure everything is right from the start. And that would be, for example, the classification. So we set up Uniclass and Omniclass classification set. It's international standard, available freely, and that is Uniclass and Omniclass also specifically focused on the FM side of things, facilities management. So that actually just makes sure that it's the same language that we talk within all the professional entities or stakeholders in the project. So if I had to draw a wall, when I pass it on to the next stage or the next stakeholder for that case, it will still be a wall. Right, and then we shared the project on the BIM cloud, which is only internal at that stage. Right, there's the existing IFC model which we've imported. Before we did anything further, we've got this from the client, and I believe it was done in Revit, and we found the IFC file on the CDE and imported it. So it's quite important to get certain things right from the start in a project, as mentioned before. So there's different things that you would do to be able to make informed decisions. As mentioned before, as I think you know, a lot of decisions are made in the beginning of a project, at stage 0, 1, but also at stage 2. Certain tools like energy analysis, which is quite important, as I'm sure everybody would agree, which can help us in making informed decisions in the beginning of a project. And also, I think it's quite important to make sure that we involve all project stakeholders from the start. That includes the facilities management. I don't think that happens often in today's projects, and I think it's quite important to think about that concept, because if everybody's involved in the beginning, we can know everything from the start and address everything accordingly, and not down the line having to make plans. Usually on site, those things happen. Right, so how do we collaborate and talk with the rest of the stakeholders on this project? So there's two different options, or in this case we use IFC, Industry Foundation Class, and BCF. So the IFC is for model-based coordination. We share IFC files, which goes back and forth each stage, maybe not so much in the concept stage, but going further, definitely. That process repeats, where we export IFC files for the rest of the professional team. They then import those information and then do what they need to do, and so we all exchange IFC files, and collectively we develop this building. The BCF is mainly for issue and change management. So any changes or issues are then, once all of these IFCs are federated, put into one model, where we can do things like clash detection and that sort of thing, which you'll hear about more later. We are able to send BCF files back and forth, which is basically sending a file, could be a screenshot or specific information to a specific professional stakeholder of the project to address certain issues, and then of course another cycle starts over where we exchange information. And that all carries on until we get to the end of that specific stage, concept stage in this case, until we obtain client approval. So client approval is obtained. We use software called BIMX. It's an app that you can download from Google Play Store, so it's available on mobile devices, as well as there's a desktop app available, and even a web-based app available. So it's a free viewer. It allows you to not only view the 3D building, but it incorporates all the technical information. So things like the meter data, fire ratings, and all of those things that you might attach to certain components, all of that would be available in there. And that also means that it's not just for communicating with your client per se. We also use that to communicate with the rest of the professional team, as well as often you can use it on site, which means you don't need to walk around with plans under your hand. I think that becoming outdated. So you've got the whole building on your mobile device or computer, but all the electronic drawings are available in there, and it's very nice being able to reference which drawing goes where, details, you name it. So I would encourage you guys to please come and have a look at our stand. We have a scavenger hunt, so you are able to go through the new portion of the Bokunda building, and you can stand a chance to win a prize. Thank you.
So, into the concept design stage, client's got this picture, and the client says, yes, that looks awesome. That's exactly what I wanted. It's cool new spaces on top of the building. It's going to be cooler than engineering for. Fantastic. I love it. The engineer says, yeah, that's cool. Does everything fit? Does everything fit? Because if it doesn't, we're going to end up doing things 3 times over. So, spatial coordination becomes a very important part of that development process, to see whether the ideas that we're coming up with early in the project actually make sense. And once that confirmation is in place, then we can continue to the technical design. So one of the tools that gets used quite a lot is Katenda. Camila is going to come and tell us a bit more about that. There are a number of different tools in the market, and I hope as you look at the examples we're showing you this morning, it's not because we want you to use specifically that or this tool, but it's to help you see what this functionality looks like, and again, keep track of this golden thread of information from the beginning to the end, and how the different tools would enable you as a professional to keep track of the information and make sure that together the team is able to yield the outcome that is desired by the client. Camilo, over to you.
Thanks, Richard.
We'll just use the arrows.
Okay. Good morning, everyone. Camilo. I am a professional architect like yourselves in the future, so I feel you. Right now you might be overwhelmed. There's a lot of information coming in, and I'm going to help you getting through that process, making life easier, because that's what we want at the end of the project. As a professional architect, I want to share a little bit of my experience on this environment. It is overwhelming. Just to recap, we are getting information from GIS, from data, from land surveyors, from engineer, from concept design. It's getting into one point. This is where I spend most of my time, really, honestly. We are going to talk about the CDE, the Common Data Environment, which Katenda is one of them, and is the one that I'm using. Arrow key. There we go. And this is where we are. Now, there is a change of paradigm in where we're standing right now. And that is that we have moved away from the 2D. We move away from the models that we used to glue when we were at the university. Now we are in a live environment, a 3D environment, where we can get in and we can get out, where we can check and we can even test and move it into the future. Now, at that point in time, there is a lot of information coming in, and this is the very best, the most important part of it. It comes in different ways, in different type of data, different type of resources, different people thinking differently about the same project, adding up to that project. And this is what we need to start coordinating. And at the beginning of the presentation, we spoke about regulations. How are we going to communicate? What is the languages? What is the rules of that language that we are going to use? And that is quite important because it sets up the quality of what we are going to produce. Obviously, we have the objectives of the client. We received all the information. We are pushing that information into the data environment, right? Which essentially are zeros and ones. It's data transformed from concept into 0 and 1 that we have to kind of reassign, redesign to produce an output. It's an industrial process, input, processing, and output. And that output has to do with what's going to happen afterwards. And that's the vision, that's the goal. So at the beginning of the process, we set up the data information, we receive it, we are going to process it, and then we are going to give it away to somebody else to take over. That's what's happened in an environment that is not static. It's live, it's alive, it's changing all the time. It's very difficult to manage. And furthermore, we are not managing our design. We are managing other people's design, and we're managing through different devices. We have the computers. We used to have the table where I learned to draw. Now we have the computers, but we have the cell phones, we have the tablets. And those things are becoming part of our life, in a way. Part of that environment is communicating not only in that space, but through those devices that we are using. And they are evolving. Maybe someday they become part of our bodies. I don't know. So this is the central environment that is receiving all the information from all the different consultants. And I think what's important here, and I want to show you this is a typical screenshot of where I work and where I spent a lot of time, is that it's not a place where we drop the information. That has changed. It is a place where we take that information, we process it, and then we make decisions based on that, on those conclusions. It's becoming a new paradigm in that sense, because it's becoming a space by itself where we can make decisions based on what we pick up from those models. And that's where all the information from BIM, all the information from geospatial information from the space, from the land, it becomes an environment. It becomes a landscape, to use a word that I'm more comfortable with. A landscape that when we look at it from far away, it looks uniform. But as we zoom in, we will identify elements that interact with each other in such a way that are forming that picture that we want to project in the future. Now, it's, like I say, it's not an easy process, and technology is changing all the time. It's evolving, and we are starting to incorporate into these processes artificial intelligence, right? And that artificial intelligence is what is helping us processing the information faster and working for us. And the point is, what I want to leave you with is, this is a tool that we have to learn how to use it to make it the process better. It's not just a space where to drop information. And this is a very important concept for you to use, because as architects in the future, you will be dealing with drawings, with models, but you will be dealing with other type of information, like data, spreadsheets, that have nothing to do with what we are used to, but is part of what we have to be dealing with in the future. Yes. And that.
So at this stage in the project, we've got a concept that the client loves. We've got all this information, and we're really working through the information, making sure that we know what we need to know to avoid the problems. Oh yes, that's yours. That's yours. We've got the same iPads. Now that process of management of information, I want to just spend a few moments talking about this. In the old days, we used to have drawing offices, drawing boards, and you'd have a drawing office manager, someone who would make sure that all the plans were filed properly or were hanging in suspension files. If you walk around this building, you'll see a lot of that. In the new way of doing engineering and architecture and construction and facilities management, that information is digital. Now, I use the example of my Dropbox account, which is it's a nightmare. Yours are probably the same, so don't laugh too loudly. In the project teams, there is a new role emerging, a coordination role, and it's a profession that is emerging of people that are highly skilled at administering those information platforms. Because if those information platforms go out of control, it's a nightmare, just like your Dropbox account. And if you've got 50 people or 100 people or 1,000 people on some major projects working on the same set of data, and that data is not properly organized. You can just imagine the ripple effects through the projects. So those of you who are tech inclined and really love that type of thing, consider that maybe as a career direction to move into. Highly technical and very strong on administrative and organizational skills, and somewhere where a lot of the AI and programming of the future is going to be focused on, is understanding that information. Camilo, thanks so much for that. So now we're going to move on to detailed design. And we're going to have a look at some of the approaches that some of you may have been exposed to so far, but what that change looks like from the old to the new in our way of doing design.
Thank you, Richard. Hi guys, thanks for having me. My name is Nathan York. I've turned 18. That's the good side. There. My name is Nathan York. I'm Managing Director of York Cross Construction. And we sort of position ourselves as BIM modelers. We are qualified, some of us in architecture, civil engineering, some of us are electrical orientated, but we've taken those qualifications and adapted it to our BIM operability. And so what we do is we assist with the teams where they get really busy in the design area, and this is where it's all nice air conditioned, and this is the pretty side of it. So that's where Camilo comes in with his architecture, and he does the design. But what happens on site is something completely different. So we take this information and we do the clash detections, we coordinate it, and we will advise. So there are some areas where it's influential from one discipline to the other. The architect would have his good idea of what would be a beautiful building, but he needs a wealth of engineers behind him to back him to make that dream come true. And each one of them share the same dream of having the asset for the owner at the end of the day. It's where these shared ideas come together, and that's where coordination becomes critical. Coordination can also influence the tracking of materials, how it gets designed, how it gets manufactured. And this is where all the different softwares come in. There's a lot of guys that use SolidWorks and ArchiCAD for product designs. And that then goes back to the architects using all sorts of the IFC files, the Autodesk files, that all the different ones come together into one CDE, the common data environment. To give you an idea, also those kind of ideas can be used where if you've got central city planning, where there was an existing building that by hook or by crook something happened, an earthquake or act of God, that needs to be demolished, but there's skyscrapers around it, so we need to worry about what is our direct environment, and then spatial planning becomes important. The actual logistics of the materials, that needs to be coordinated, because if you've got a building being constructed, that needs to be planned. So we help with those coordinations, and you guys are welcome to come and check us out. This is what was designed and what was built. So it looks pretty in a nice hot office. And then those guys with the hard hats, they go and build this, and that is nowhere close to what was designed. Okay? And then it goes back to that data capture that Sam was talking about and the other guys were talking about. That data capture goes back and says, okay, well, the facilities manager looks at his drawing and the valve's on the one side, and he gets there and the valve that he needs to close is actually the other one. And he shuts the wrong building off. So those kind of plannings and coordination, that comes into play. This is one of our live projects at the moment. We are still very much coordinating this. And this is what it looks like before your pretty ceiling goes in. I guarantee you that the bowkunda looks like that behind the ceiling. Believe you me, that's what it looks like. Okay? So the architect, he designs his pretty ceiling. Electrical engineers make it light up. Mechanical engineers make it comfortable for us to sit and breathe. That's where we come in. If you want to know more, I'm going to leave you on a little cliffhanger over there. Come and see us, we're on the second floor. Cheers, guys.
Then we reach that amazing moment where the design is completed, it's ready for construction, everyone is excited, go through the tender phase, we break ground, we start building. Now, as a professional team, One of our biggest concerns is making sure that what's getting built is actually what we intended to get built, and keeping track of what's happening on site, being able to manage changes, etc. So the next few workflows and technologies we're going to be looking at is how we use tech to track and make sure that site is happening as intended. So as we move on to build it, tweak it, change it, manage it, and record it, invite my colleagues up to come. Open Space and Baker Baines.
Okay, thank you, Richard. Jaco Barnard, it's good to be back at this university. I did study here, I can't tell you when, but
You can't remember.
No, but I did figure out if we did have email, my email address would have been u8754179@tux.coza, but I can't share more than that. Okay, so Jaco Barnard, Agile Business Technology, we've got to stand out there, come and talk to us. One of the solutions that we represent in Africa, Sub-Saharan Africa, is a product called Open Space. And what Open Space helps us during the construction phase of a project is to ensure that we are linking the head office, the office to the actual job site, because not everybody is able to go there on a daily basis. Okay? So what we do see happening currently when people go to job sites and they would like to document progress on a specific day, they would take out a phone, they would take a series of photos, and in a lot of cases there's a WhatsApp group created for that project. 100 photos get dumped into that WhatsApp project group. Now that's not very useful, because if you need that photo in 5 years' time, trust me, you will not find it. Okay? So what Open Space does really, it's a 360 camera, commercially available. You can buy it on Takealot. It's got a specific bracket, and what we do to capture job site progress is effectively put the camera onto the hard hat with a magnetic mount. We put the hard hat on our head, and effectively all we will do is link the application to the camera on my head. The instruction to the camera at this stage is please take a 360 photo every half a second whilst I walk through the job site. So, easy way to explain what we're doing, Google Street View for projects. Okay? So this camera is the camera that was on the Google Street View car that drove past your house or your apartment or your deck, and you are effectively the Google Street View car which is walking on that job site. It doesn't need to be on a hard hat. If we want to inspect the facade of a building, there are very specific 360 cameras that can be mounted onto drones. But here is the process. We go, we walk, capture, upload, that becomes available for people sitting in remote places. So we don't all need to go there. And very important for us to capture the information as we're building up what we call a time machine is, once again, post handover, facility management would like to see what is behind the drywall, what's above the ceiling, where were those services actually installed. As Nathan said earlier, you know, we can't really trust that it was installed as per the design. There is a concept that as built should be updated. Trust me, when you go into practice, that will still not happen. Okay? So we need better ways to capture these as built. Now, once we've got the reality capture there, what we're able to do obviously is start comparing the design to the, as we are busy building, and that way we can sit in an office 1,000 kilometers away. Consultant doesn't need to go onto site because he can start comparing the design to the reality and the reality capture, as Louis explained earlier. So this is just another form. This is not scanning. This is capturing. It's photogrammetry of that condition on site on a specific day. So there's a whole bunch of other features as well. So scanning traditionally would have been those scanners that we put onto a tripod. It is a process we need to go through. Those scanners are sometimes very expensive. But should the person on site happen to have an expensive phone like an iPhone Pro, iPad Pro, those phones have got built-in LiDAR scanners. And with OpenSpace, we are now able to do a LiDAR scan of a specific object, send it to somebody sitting 1,000 kilometers away to be able to measure that specific object. So here's just an example of the capture we've done in the building. And on the right-hand side, that's the IFC model that was uploaded of this building. So if you want to learn more about OpenSpace, please come and talk to us. We can show you a little bit what it looks like. We do have a scavenger hunt, and so you can win prizes, but you need to then first remember my student number. Okay.
Morning, everyone. Unlike Yaku, I did not study here. I studied in Johannesburg. My name's Yanni. I'm also not going to give you my student number, mostly because I can't remember it. So, one thing that I don't think it's mentioned really, but typically construction is where things tend to go wrong. And if the new Bokenigbo is Khalid's baby, this is the birth of that baby. And for me, in terms of where BIM fits into this construction stage, and specifically when you think about it more as information management, is that you really should leave no room for interpretation. There's a very funny video about this, but basically it starts by someone telling Kevin that he needs to redo a wall, and it goes through this game of telephone where it ends up between demo it all, fire the wrecking ball, and someone ends up building a waterfall. So that is the type of thing that can happen if you don't manage information correctly. So yeah, I'll come to your stand, I'll give you the link for that. Now at this stage in the BIM journey, I'm assuming that all of my colleagues and all of the teams that happened kind of from stage 0 up until stage 4 did everything perfectly. We've got a BIM model, it's got information in, things were coordinated, we had accurate information right from the start, we've got tight briefs, we've got information requirements, and I need to take all of that and now go and build it. Now there's multiple different things and aspects and workflows that BIM can play in. I'm not going to go through a list of all the different technologies and all of the things, machine control, prefab, root cause analysis, checking what your contractors are doing, so many different things. The main things that I wanted to talk to you about today is we've heard quite a lot about scanning and reality capture because it's a big part of what happens in the beginning. So in the beginning, before we start building, let's stay with the boat, and we made sure that we knew the environment, we knew the building, we knew what we were dealing with. Now that we are building, there's a new aspect of reality capture. Yaku spoke about this, taking those photos, but you can build on that by also not just having the 360s, and in some cases also doing your LiDAR scanning. And you can see different pictures, can be a drone, can be a phone, can be different scanners, and from there you can start doing some construction monitoring. Basically saying, guys, this is what we had to do, this is where we are, how far are we off track? Now, from a scanning point of view, if you're going to scan your site, it's not necessarily something that you will do every day, versus putting something in a hard hat and walking around, maybe something that you do every day. And then the idea of this is when we start capturing this information again, we can start to make sure, like, how far off are we? We have this design intent and we've got all of this information that's been given to us. What are we actually building? Now, as someone who's currently renovating her house, I deeply feel the pain of not really knowing what is there. But from a scan, you can compare your scan of the actual building to what was designed, and hopefully pick up some of those discrepancies and course correct. Not only just in terms of placement, but we can look at other types of discrepancies, floor leveling, buckling, those types of things. And in an ideal BIM world, we then adjust our model to make sure that If the pipe was meant to be here, and I now builded it here, let's update that in the model, because like Lade said earlier, we need to think of the next person. We need to pay it forward. And what's happening after this is I'm paying this forward to the client, and the client will really like to know where his pipe is, so that when he starts upgrading that building in 70 or 50 years down the line, we don't see any issues. Now, part of that kind of construction verification is you're managing the quality of things. Now, in terms of managing the quality of things, how do you capture and take that information so that it's not just thrown into your own personal Dropbox folder and someone needs to go and figure out what do they give to the client at the later stage? From a quality inspection point of view, I think really all different types of inspections and aspects of what happens on the building site can be integrated to what everyone else is doing. So it's that idea of, again, connecting the teams, connecting what's happening on site to those sitting in the office or those that aren't on site all the time. So in the digital world, these quality checks, inspections, snags, safety, all of those types of things can be done in a digital space where it's referenced to what else is going on. And it really plays a big role in the construction management side of things, because we've got all of this information. How do we take that information and use it to our advantage when we start to track and manage stages, when we start to look at RFIs, when we start to look at the potential change orders that comes from that? What kind of defects, what kind of budget impact are we looking at? We've heard that the client has a very limited budget. Pretty sure they also have a tight deadline, because it's always like that. Those things are linked into that common data environment, and all of this collaborative effort that we've seen up until this far isn't lost when we start going into the construction industry. Do you want me to just carry on, or do you want to jump in?
I'm going to move the tracker along. So now we get to a very, 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 very important part, which is handing over the right information. And we've actually got some colleagues from asset management and facilities management here. And in conversations, the quality of information available to the engineering team that actually runs the facility is incredibly important. If you've got bad information, it's like running through a china shop blindfolded. You don't really know what you're running into, and you discover stuff along the way. But there's hope. Because now with proper workflows, with good information management, and what Yoni's going to take us through now, the opportunity that we have as project teams is to collect that information really well and make sure that we hand over good quality.
Thank you. Mine is brief. I was told I have 5 minutes. So, at this stage, we're basically sending the baby home, going, no more nurses, no more helping, here, take care of it. And if we look at some of these stages similar to what we've seen before, and some of you may have heard these terms from a BIM world, this is really that final stage where things go from a project information model to now an asset information model. This is where all of the things that the building owner and Khaled said in the beginning, going, this is what we need in order to kind of manage this facility, and this is what we need to get out of this. We now need to get that information, hopefully not all in pieces of paper in a wheelbarrow and go and drop it off at our office. We need a BIM and a better way of doing that. So again, we're assuming that everything up until now happened accurately. Our building, our construction went as well as expected, and kind of everything that happened during that construction stage was accurately captured in a common data environment. It's time to really check all of our assets, do the commissioning, make sure that we're making sure that those defects are fixed, that all of our warranties and our manuals and our spec sheets are in one place, well structured. When Richard spoke about the Dropbox, I too have a similar Dropbox. And for anyone who's ever seen extreme hoarders, I sometimes feel like we're moving into this new world where we're like becoming digital hoarders, because you just, let's save this, let's save this, let's save this. Which is great because we can, because it doesn't take up physical space, but it's very important to be a structured digital hoarder. If I can put it to you like that. So from a technology point of view, the generation of the turnover documentation, we're taking you back to what happened in the beginning, where those information requirements were set. You need to now make sure, this is the final step to go, we need to make sure that the information that we've generated meets those information requirements, and also the information that we're handing over meets those information requirements. And again, structured. So all of this, we're on the top floor, so if you want to start with the end in mind, you can go top floor down, but what is this tool, what is that, I'm not going to mention this now. And hopefully, just hopefully, the client actually gets accurate as-builts. Or as-builts, I think everyone calls it as-builts, but it's more kind of like as it was designed, like actually as it was constructed. Because that really, again, pays it forward, and that adds massive amount of value to how that project information model is moving to the actual asset information model. And all of this in a common data environment. Multiple different ones, I can tell you which one I like. Like I said, structured information. Information that someone can find and hopefully use 10 years down the line. And I specifically say that and use because think about the format and the usefulness of information to an asset owner down the line. Do they know where their pipes are? Do they have their manuals? Do they understand their mechanical equipment and everything else that's part of their facility? That was my 5 minutes.
Well done.
Yeah.
So now this is a part of the world that is very new. Traditionally, I think a lot of the construction world is focused around building stuff. And as Khalid's intro reminded us, because so much of our lifetime's experience of a built world is already built, the focus of being able to manage things well is becoming sharper and sharper. And so in this next section, we're going to talk about how that information might help us. What does that information look like? What type of information might we be interested in managing the facility, managing the future Bokende building? So Rudolf, you're going to come and show us a bit more about how the information systems can then help us to understand what information is being used in that operations and use stage. Rudolf?
Thank you. Yes, thank you. So what I want to just talk about is throughout all these stages that we've been discussing, Esri does provide a tool called ArcGIS BIM, which brings these two worlds together, where you have the construction cloud and the GIS side talking to each other. And this kind of creates a common data environment as well, that we may not be on the same environment, servers or anything, but can talk to a different organization, different platforms. I'm not going to go into this detail. This is a common picture. But the idea is that GIS plays a very important role. As I mentioned earlier, that it's where we build and things like site selection, feasibility studies, and so forth. And then the combination of GIS and BIM gives you all these benefits, like reducing costs and reduce material usage and so forth. And going back to this common data environment that we're talking about. So what I want to quickly just show is also what we did at Stellenbosch University, is this common data platform is the visualization and the integration of all these different systems. So here you can see we've got all the buildings that are just a footprint that's been extruded, because there's no BIM models for all these buildings. So it's just an indicator of where the buildings are. And you can see also we've got OpenStreetMap in the background and trees and all the other infrastructure that we spoke about earlier. We can overlay the aerial photography, the terrain, everything on top of that. Plus we can then use, as I mentioned earlier, a feasibility study or site selection tools within GIS. And here we've identified an area for new student housing. So it looks at all the infrastructure, utilities, so forth, and this is the place we're going to build. And then we can also look at things like security. Where are we going to place this, a CCTV camera? So are there any obstructions that would create a dead spot for the cameras, and more crime can happen in those areas? There's just another view, so we can see there's some trees obscuring the visualization of that camera. But these are kind of the analytics that we're talking about, that GIS provides that kind of mechanisms. Then of course we can bring in our BIM model in the right location. Earlier we spoke about that accuracy. So you don't want to see this building in the middle of the sea. So you want to be able to, when you design the building, it must be geographically correctly placed. We've seen it so many times when we work with Rivet and IFC models that we utilize. They either sit in the air, in the right spot, but they're too high or too low, or underground. So be aware of that. That's a fundamental part of this common environment. We want to bring in different data sets that they're all geographically placed correctly. So we're going to be able to plan much better. So we can see here we have total interactive access to that BIM model as well. Now when it comes to operational management, when we've delivered the project and now it's going to be operationally managed, we can have things like utilities. There's a fiber network. There's problems with the fiber network. We need to send out technicians to go and investigate. They can be dispatched to the specific areas. They can take photographs, they can do surveys, they can do condition assessments, all those kind of visualizations, and we can see how many work orders have been assigned, where are the techineans. So please come join us at the at our stand. We're going to do quite an interesting exercise, scavenger hunt, to simulate this kind of work orders and technical assessment. So these dashboards runs in operation centers, and people can visualize that. Then we also have the ability to show condition assessment of assets. Where are the assets that's going to give us problems in the future? So we can start seeing hotspots of problematic, deteriorating infrastructure, pipes leaking, gas pipes like what happened in Johannesburg. So we can then start forecasting and predicting where those problems are going to be by using these type of analytics and so forth. So now what about in accessibility, an interface so we can see everything. So we've got the common data environment where all the data is available, but now I'll be able to use it, like a user interface, user experience. So this is something that we designed in part of our software called Experience Builder. And again, what I mentioned earlier, there's no coding involved. This is all almost like PowerPoint, where you drag and drop and you paste things on a screen. And it gives you that environment that you've totally accessible. There again is the Stellenbosch map that's embedded in this environment. We can also bring in the site selection tools. We can bring in our mobile applications, which is available to our field workers and our technicians. And we can also embed those dashboards. And it's all interactive. And we can also share it to different parts of the organization, people that need to have access to things, and people that is not supposed to see certain things. But its ability then to have access to this whole environment. And the GIS is one of the tools that will help us to get this kind of access control. And lastly, please join us at our stand. We're going to have this scavenger hunt with all these little characters that we're going to catch at the campus. And just as we're sitting there, you can download the ArcGIS Field Maps application. For those of you who want to join us, you can download that so long from the Play Store. And with that, thank you very much.
We're almost home. We're almost home. So now we've been operating and enjoying the facility for how long? 100 years? 100 years. And we've got to the point where we now need to take some decisions. And Kaleid's going to talk us through, as the owner, she's now very old, she's 100 years old, she's been in the building all along. And she's going to tell us what next.
So this stage of BIM is very new. Most of BIM and twinning, like Rudolf was leaning into, is about the now. But in 100 years, we have other problems. And with 100 billion buildings, some of those problems are already here. But imagine in 100 years, Bouwkunde matters much more than it does today. And it's a very important building. It's a building that has meaning, that has legacy. It's a historic building. It's a heritage environment. And in 100 years, everything else around Bokene will look very different. We might have spaceships, we might be on Mars, we might not even be here. But the point of it is we want to memorize and keep our histories and legacies alive. Or we want to destroy the building and decommission it in a responsible way, not just send it back to the landfill, which we will not do. So stage 8 is thinking of the 100-year future and how you're going to hand over your legacy to the heritage and decommissioning of the building. And this is an incredibly interesting field that I'm not the expert in, but we have experts here for you to go visit. HBA Architects are heritage experts, and they're starting the Heritage BIM journey, and they're exhibiting on the ground floor, and I'd love you to go ask questions about how do we preserve our legacy environments, how do we preserve our futures, and what kinds of technologies and detail we need to go into to make sure we take care of our environment. All of us are living in the built environment. It is one habitat, and we will eventually need to take care of it, not just demolish it. So on the one side, we have heritage, and please go visit them. It's an active project that we're busy with right now. We're scanning the heritage buildings of the University of Pretoria, and we're classifying them for heritage BIM, and there's all sorts of interesting things happening about that. A lot of this we'll discuss tomorrow in our case study, which students, you're also welcome to join it, but it's for you teachers specifically. And how we need to work with heritage information, legacy information, and carry it forward to preserve, to protect, or send it back for circularity and reuse. We cannot be living in 100 years in a world where we extract and mine and dump everything in a garbage dump somewhere else. The built environment's responsible for a lot of junk, terrible junk. And we keep on producing that, and we keep on mining that. And so stage 9 of BIM, this is a very, very new environment, is about saying how we stop linear work and how we start circulating our environment. So we'll also be speaking about that tomorrow as a case study in the teaching space. You're welcome to go check it out. And the honors students, hands up, honors, yeah, those bunch, yes. They can help you and ask them questions about it. They're studying this topic for BIM for circularity, BIM for reconstruction, BIM for heritage, in quite a lot of detail. And their work is up downstairs, and please ask them these questions. How are we going to mine our cities so that we do have a responsible future? How does information get mined? How do physical things get mined? How do we prepare the 100 years in the future for that world? That's what we need to do as a community. And it's not just architects or engineers or contractors that do it. It's everybody who's part of the built environment. So stage 9 for us is we're seeing something very useful and interesting coming about. That if we do better information management about the built environment, these are very powerful tools for us to circulate our resources and produce much more value than just today. So we see BIM and twins, which we're not talking about today, but maybe next BIMHarambee, as vehicles for a circular built environment, but it starts at stage 0. It starts with intention. It starts with that culture that we will honor these principles, and how are we going to work together to get there. So with that, does this help? Does it help to see the whole thing stitched together? Have you had this experience somewhere else before? Does it make sense? Okay, that's what we wanted. So for the afternoon, we're going to release you into the wild. Did you all get a sticker with a color on it? Give or take. All right. The building has been set up according to these workflows from the ground floor to the top floor. Please start every quarter to the hour at your location, and then move yourself through the building. Ask all the questions, play with the toys, make friends, figure out how you are going to be part of the legacy of the built environment. All right. So with that, we'll let you go run wild. See you at 11:45. Have fun. No, it's fine. I need a breather. Okay.
See you downstairs.
See you downstairs.
Are you going to bring that projector? You'll bring the projector?
Yeah, bring the chair.
Thank you very much.
Thanks, Camilo.
I really enjoyed this.
Good.
Thank you. Nice meeting you.
Speed presentations.
I was afraid we're going to run over time, right?
I like the format. It's quick, and I think because it was quick, I think the students were engaged with listening to new voices. Empty the cup the whole time. Okay, cool.
Thank you very much.
We're early.
I'm just going to stop the stream.
It's fine. And